This episode of the HVAC School Podcast is made possible by our sponsors who really do make this possible. I just want to say that again. I do a lot of this stuff now. Obviously, I run a business, and this does take away from it a little bit, although, of course, our employees benefit from it. But to put this much work into it, we have to have some support. And these sponsors are the ones who help support us, and they provide us with content and ideas and feedback, and I really do appreciate them. So let's mention them. Carrier and Carrier.com. Carrier's been with us from the beginning. They're the manufacturer that we sell at Kalos, and I like a lot of the things that are happening. We actually gave some feedback on something with the ductless systems just a week ago, and we got word that it went all the way up to Indy and that they were making the changes that we had suggested. And it's pretty cool. It's cool when you can have people actually hear you, and that's what Carrier did in this case, and I appreciate them for everything that they do. Also want to thank navacglobal.com. They make all kinds of great tools. They got some really interesting tools coming out in 2019 you're going to want to take a look at. They have their new charging machine that has temperature clamps for superheat and subcool, as well as a scale and an integrated vacuum pump. And they also have their battery-powered 2CFM vacuum pump, which is interesting for certain applications, like if you're working in some refrigeration situations that are hard to get a cord to. So there's some interesting stuff they're making, and you can find out more by going to navacglobal.com. Airoasis.com/go, makers of the bipolar and nano products, induct, easy-to-install products, great made-in-America products. Find out more at airoasis.com/go. Also, refrigeration technologies at refrigetech.com, makers of Viper, Dialog, many other things, refrigetech.com. And then finally, Fieldpiece. Fieldpiece, I've especially been using their vacuum pumps and recovery machines. Those are pretty new to the market. I've put them out there with some of my most discerning technicians, like Eric Melly down in South Florida, and the feedback has come back very positive. Really, really nice machines, very light. The oil management on the vacuum pump is great. The recovery machine and the digital display is excellent. A lot to like. You can find out more about the Fieldpiece vacuum pump and recovery machine by going to TrueTechTools.com, TrueTechTools.com. Use the offer code GETSCHOOLED for a great discount at checkout.
And now your host, the guy who checks the air filter of every single hotel room right when he walks in, but still can't change his own filter when he's supposed to, Brian Orr.
This is the HVAC School Podcast, the podcast that helps you remember some things you might have forgot along the way, as well as helps you remember some things you forgot to know in the first place. And I'm Brian, and today we're going to be talking about ventilation. We've talked about ventilation in the past, this or that, ERVs, HRVs, ventilating dehumidifiers, but we have never talked about it soup to nuts. And today I have the guy who is just nuts enough to talk about it soup to nuts. That's John Semmelhack. Really good guy up in Virginia, somebody who participates in the group, our HVAC School Facebook group, and we're going to go through it from start to finish, talking through primarily the topics that are addressed in aSHRAE 62.2 that relate to outdoor air, but we're going to talk point ventilation and everything in between. So here we go. John Semmelhack talking ventilation. Thanks for joining us, John.
Thanks, Brian. Good to be here.
Great to have you. A topic I've been wanting to talk about for a long time is ventilation. We've touched on it here and there, but I haven't done the comprehensive podcast on ventilation. And Neil Comparetto, who I think is a friend of yours, called me out and said, hey, you need to do a podcast on ventilation. You need to have John on. So yeah, I appreciate you taking the time to do this and share your knowledge in ventilation.
Yeah, thanks, Brian. Thanks, Neil, too.
Before we get into talking ventilation, I want to give you a chance to tell us a little bit about what you do. I know your business is Think Little. Tell us about how that got started, what that is, and how you got into this business in the first place.
Sure. I started the company Think Little in 2008. We're a small home performance consulting company, 3 people right now, based in Central Virginia. And we do most of our work in the Central Virginia market with a couple of exceptions. So we're in Charlottesville, and that's most of our work is in Charlottesville, Richmond, a little bit up in DC. I got into the field when my wife and I decided to try to build a house in the early 2000s. And I didn't have kids at the time and had a lot of time for research, both in the job that I had at the time and off the job, and just got into the world of residential energy efficiency. And the more I learned about it, the more interesting it became. And I found out about the world of home energy ratings and energy audits and things like that, and decided to jump in and start a small business. I've really been kind of in school ever since. I'm trying to constantly learn about all sorts of different topics. That's kind of where we are now. We work on a range of houses from single family to multifamily. Everything's fairly high performance to extremely high performance houses. Most of our work is in new construction right now. We do a little bit of existing home work, and we hope to do more existing homes in the future.
And where does most of that work come from? Is it from contractors you work with regularly? Is it homeowners who are seeking you out?
It's an interesting mix. So we work with home builders, architects, homeowners, multifamily property developers. And as consultants, our job is to help them build better buildings. And the things that we focus on are comfort, indoor air quality, energy efficiency, and durability of their buildings. Most of our clients come to us for energy efficiency, and we help them get those other items, the comfort and indoor air quality and durability, while delivering really great energy performance.
So when people really want energy efficiency, like I'm thinking of something like a passive house, which I know you've done some work with, what is their why generally? I mean, is it really to try to save money?
Sometimes it's a little bit to save money. I think the main reason is because it's just a fantastic product. It's just a fantastic house, superior comfort, indoor air quality, and energy. So some of it's definitely for environmental reasons, some of it's for operating cost reasons. But in general, it's just you're helping them get a superior product, no different than a superior car or computer or airplane or what have you.
It's a combination of a lot of things, but in a lot of ways, it's just looking for a premium result, premium product. It's the same reason you would buy a Porsche over a Volkswagen sort of thing.
Exactly. Yep.
We're talking about ventilation today, and ventilation is one of those kind of hot button topics. I had Jack Rise on the podcast a couple times, and he's a trainer. He's written a book for ACA on Manual D and Manual J, so 2 books for ACA on those 2 topics.
I listened to those, yep.
Jack is of the opinion, and he's been very vocal about it, that the problem in his mind is that we're building houses too tight. And so the reason why we got to do all this ventilation stuff is because houses are just built too tight, and we should just go back to the good old days when they were built nice and loose. I'm not putting words in his mouth. That is really how he feels about it. So I want to just kind of address that right off the bat, because I know anytime we talk about this, there's going to be this cohort who's going to comment on it in that way. So what would be your thoughts on that, a way of looking at ventilation?
So we look at ventilation and air tightness of houses from a standpoint of control. So the tighter your house is and the better your ventilation system is, the more control you have over the amount of outside air that you're bringing in, the temperature of that outside air, the quality of that outside air, and the energy impact of that outside air. If you have a leakier house, all of those things are kind of random, and you don't necessarily get the right amount of air at the right times, at the right quality, and you pay extra for it. So kind of the way we look at it is you build tight and you ventilate right, and we take that to the full extent of those words. We try to eliminate in our new construction practices all of the air leaks, get down to passive house levels of air tightness so that we have full control over the outside air and indoor air.
All right, so real quick, let's define this word passive house, because I'm sure there's a lot of techs who don't even know what that means. So what is that all about?
A passive house is an energy efficiency standard that was originally developed in Germany, in part from some super insulation concept buildings that were built in the Northeast and in Canada in the 1970s. One of the big parts of passive house is that it has a very strict air tightness requirement. So for those of you who are familiar with the blower door air tightness testing requirements that are in the current energy codes, the passive house levels of air tightness are around about 5 times tighter than the energy codes. In that ballpark, it varies a little bit depending on your climate. So from an air tightness standpoint, that's kind of the metric that we shoot for on our very best new construction projects.
And I think even for the regular home, so for most people, passive house isn't something that you're going to achieve, your average homeowner. But one thing I like about the fact that it's going on is that so much has been learned about air tightness and how to handle things when you start to get into tighter situations and how to achieve really high energy efficiencies, even for regular houses. I kind of almost look at passive houses as kind of like the NASA, where you have all these products and ideas that come out of it. It becomes almost like a think tank or a testing grounds for new products.
Yeah, I'd agree with that. I think we like to think that there's a good bit of trickle down of products and technologies and techniques from the passive house world into other buildings.
So let's dig into the specifics of ventilation. And we're going to talk about residential, commercial. We've been working with ventilation and commercial forever. I mean, as long as I've been in the trade, that's been a consideration. But it's a newer thing for us to have to think about ventilation in a thoughtful manner on a residence. Let's really just start there. And I'll let you kind of take the ball and run with it. How should a AC technician, AC contractor be thinking about ventilation in a way that's different than just, I put in bath fans, I put in a kitchen exhaust. What else is there to know?
That's a good place to start, though, is with the local exhaust requirements for bath fans and kitchens. But going beyond that, there is a need, especially in the tighter construction we have with new construction, to provide whole house ventilation, which is really the goal there is to dilute indoor pollutants with presumably cleaner outside air. We can get into how that's not always the case and what you do about it maybe later on. But the idea is to bring in that outside air and to dilute pollutants and reduce the overall levels of different pollutants inside the house. And those pollutants might be things like fine particulates, odors, moisture, volatile organic compounds coming off of cooking or perfumes or all kinds of different things, all of your furnishings, for instance. And then kind of the next step is really thinking about how you want to introduce that outside air into the house and think about the energy impact, the impact on the loads, the impact on air quality, the impact on moisture levels in the house, depending on where you are in the country, and try to figure out what's going to be the kind of optimal solution for a particular building or a particular client.
So let's talk about your design approach as it relates to the ventilation portion. Say you're doing a design for a new home, new construction home, and you're considering ventilation. Where does that start and end, and how do you kind of think about that?
For any new construction project we're working on, it's not even a consideration. It's a standard. It's a default. Every house that we do gets ventilation system as part of the design. So where we start is with the aSHRAE standard for ventilation, which is an American standard for ventilation rates. And generally speaking, the aSHRAE standard is where the building code ventilation rates typically come from, or in that ballpark. So we do a calculation that's based on the number of bedrooms in the house, the floor area of the house, and with the new aSHRAE standard, our expected air tightness that we confirm in the field later on. And we get a whole house continuous airflow rate. So that might be in the ballpark of 90 or 100 CFM for, let's say, like a 3,000 square foot, 3 or 4 bedroom house. So that would be a continuous airflow rate. And then the next step that we do is we start to think about, okay, so what kind of equipment choices do we have to deliver that airflow? Are we going to deliver that airflow continuously? So 100 CFM, 24/7, 365 days? Or are we going to deliver that intermittently, where we say deliver 200 CFM for 30 minutes out of every hour, or maybe 200 CFM for 12 hours out of every day, or something like that. And that, of course, impacts the different equipment choices because that gets you into different choices for fans and duct sizes and controls.
All right, so talk a little bit more about this idea of continuous ventilation versus timed ventilation. How do you go about deciding whether or not continuous ventilation is the best solution, or whether or not you would only do it for certain times of day or during certain conditions?
Continuous ventilation is, in my opinion, the easiest to set up because the system just runs and there's no real occupant input into the system. There's not a big amount of extra setup that's required from the installers. But there's some situations where, I guess in terms of pollutants that are being introduced to the house, most of those are being generated indoors, and many of those are being generated when people are in the house. So there's a certain argument to be made for reducing ventilation flow rates when the house is unoccupied and increasing ventilation flow rates when the house is occupied. And that's something that you would see would be pretty typical on a commercial building. And you can do that in a residential building, but it starts to get into more complex controls, more complex ventilation systems. And in homes, we don't have like a facility manager, maintenance staff on hand to help set those things and make sure that they're running properly. So we tend to err on the side of continuous operation and simplicity in terms of the ventilation controls.
Makes sense in residential. So when we talk about treating outdoor air, and you alluded to this a little bit earlier, that sometimes our air may not be necessarily fresh air. It may be warm or cold or high humidity. It may have different contaminants in it that we would rather not have in our space. What are some strategies that you use to mitigate that or deal with that?
The filtration is, I guess we have filtration for particulates. We have for temperature, there's a couple of different options. ERVs and HRVs are one option, which are balanced ventilation systems that transfer heat or heat and moisture between the airflows without transferring air molecules. So that's another option for conditioning. And then you can also bring in the outdoor air and mix it with return air. So that's another way of kind of tempering the indoor air by mixing it with room air. And then, of course, you can bring in the outdoor air and run it through something like a ventilating dehumidifier that's going to take the moisture out of the air. So we like to kind of think of those from distinct silos, I guess. So from a filtration standpoint, we start, I think that's in the aSHRAE standard. I think MERV 8 is the minimum filtration level on the outdoor air. And we generally would like to see something higher than that in terms of the particulate filtration, especially if you're working in a project in a fire-prone area, like just about everywhere in the Rockies or west of the Rockies. That's a lot of houses. You'd want something more like a MERV 13 or higher, or maybe even HEPA level of filtration on the outdoor air so that you can actually ventilate even when, from a particulate standpoint, the outdoor air might not be all that great. So there's cases where you might still want to ventilate for other things that are going on in the house to get rid of indoor pollutants, to get rid of carbon dioxide buildup in the house. But you have to take care of the particulates or the moisture or the temperature issues that are outside.
You mentioned carbon dioxide, and I want to mention that quickly because a lot of people will tout different new indoor air quality products, and we use some of them ourselves. We use a couple products by Air Oasis from time to time, and they're good products. But some people will tout that, well, I don't need outdoor air because I'm doing such a good job of filtrating. But carbon dioxide is something you can't get away from. I mean, that is the one thing that you really need outdoor air for. And as a perfect example, I did some monitoring during Thanksgiving dinner this year, and to see the rising carbon dioxide levels when everybody was in the house and we were doing cooking. We had some of the chafing dishes with the little candles underneath, so on and so forth. And our carbon dioxide levels were really spiking to not necessarily dangerous levels, but up to the point where you start to get headaches and things. And so carbon dioxide is something that we've got to deal with. And I don't know of any strategy to deal with carbon dioxide other than bringing in outdoor air.
Right. Yeah, that's exactly the case. And so it's really coming up with solutions to allow you to ventilate even when the outside air isn't perfect. If the outside air was perfect, then you just open the windows. So yeah, filtration is one thing. From a moisture standpoint, that's going to be the moisture levels of the outdoor air are going to be the big concern everywhere kind of east of the Rockies. Not so concerned about the forest fires, but moisture is a big deal, especially in the southeast. So how are you going to deal with the extra moisture that comes from the ventilation air? Or in some cases, it might not be that much extra moisture, but just kind of acknowledging that there is, especially in the summertime, more moisture in the outdoor air, and how are you dealing with that? Making sure you're accounting for that in your load calculations, making sure your heat pump or air conditioner can deal with it, and or installing dedicated dehumidification equipment that can handle that extra moisture load. I think kind of our gold standard for installations would be to use an ERV that will reduce the amount of moisture that comes in from the ventilation air compared to just straight outside air. and then have a dedicated dehumidification system that's just recirculating air inside. And if moisture levels get too high, then the dedicated dehu comes on to take care of that.
All right, this brings up one of my biggest questions, and I ask a lot of people this, and I honestly don't know what the best solution is, but if you're in a humid environment, we are in Florida, Gulf Coast states, very humid environments, if you're bringing in outdoor air and you are dumping that outdoor air to where in order to prevent there from potentially being condensation when that outdoor air makes it into the conditioned space?
So you're either delivering that outdoor air directly to the rooms that are occupied or most likely to be occupied, such as the bedrooms where people are sleeping overnight, or maybe living rooms, dining rooms, something like that. So that's one option. And then the other option is you're delivering that air to the existing HVAC ductwork, and it's mixing with the rest of that system, and then it's getting delivered to whichever rooms are being conditioned by that system. So in terms of, I guess, condensation risk, if you're delivering it directly to rooms, then your surface temperatures in that room in relation to the dew point of that outdoor air are really critical.
Right, which in general means that you've got to think about, because this is something we've run into several occasions, is that you've really got to think about the occupied space temperature. Set point becomes kind of critical, because if you have, in our marketplace, a lot of times contractors are just, in fact, most commonly, they're just bringing a duct in from the outdoors and they're just dumping it straight into the return, generally not running it through any sort of ventilation blower or anything. They're just dumping it straight into the return. And of course, that's not an adequate way of doing it. But what we see in a lot of cases is where that outside air hits that return airstream, it condenses, and you can only imagine what else occurs there where we have moisture. Do you have any thoughts or solutions to that? I mean, I know you probably weren't prepared to answer this question, but it is something that we run into, and I don't necessarily have a great answer to that, because one answer is, yeah, you need to make sure that the space temperature isn't below the dew point of the outdoor air where it enters.
Yeah, but that's impossible to do in your climate. So, I mean, you probably average mid-70 dew points in the summer with peaks well over that. So that's not really an option. So I think what you, in those situations, in those high dew point, high humidity outdoor areas, I think you really have to do some type of preconditioning of that outdoor air before it hits the return duct or return plenum, or before it's delivered to the space. So that's either going to be a ventilating dehumidifier, or that's going to be an ERV that can knock down the dew point enough that it gets below the surface temperatures.
And just to call out quickly, because we've mentioned ERV and HRV, some techs may not know what those are. And essentially what you're doing in an ERV or HRV is you're exhausting the same amount of air that you're bringing in, but you're crossing those airstreams, so that way there's a transfer of heat and sometimes even latent heat, so moisture. And an ERV transfers both sensible heat and latent heat. So you're going to see a drop in dew point. It may be significant or it may be insignificant in some cases. And in the case of an HRV, it's just transferring sensible heat. So you're not going to see a change in the dew point.
Right, exactly. So in the climates where you have high outdoor moisture levels, certainly in the commercial and residential world, an ERV is going to be a more appropriate choice there compared to an HRV.
All right, I want to take a quick second here to mention one of the companies that I'm really excited to work with, very, very excited to work with, very pleased to work with, and that is Refrigeration Technologies. That is John Pastorello and his son Mike Pastorello run that company, and they're just great people. It's great products. You're going to find them on a lot of shelves nowadays. They've done a good job, actually, of increasing their distribution. But for products to do well, you need people who are willing to take a chance on them, willing to try them, willing to buy them. And if you haven't tried Refrigeration Technologies yet, then I'm going to make a personal request for you to give them a try. They've supported us here, and I think you're really going to like it. Your customers will like it, that's for sure, because they don't have strong odors. They try to make their products as natural as possible, safe for technicians to use, safe for customers to breathe. Those are the Viper cleaners. They make the original Viper cleaner in a spray can, which I was skeptical of at first, I'll be frank. I thought, man, those seems like that's not very much product in that little can, but man, does it come in handy. It makes this really nice little pin spray. And when you're working in tight areas, especially like maybe a refrigeration condenser or a refrigeration evaporator or something, or maybe a clean in place on an evaporator coil. They're just really, really nice little cans to have on the truck. So that's one of many products. If you haven't tried Nylog yet, I'm definitely going to suggest you do that. Everybody who tries it loves it. I haven't had anybody yet who's tried Nylog and said, I don't care about that stuff. It's great for your vacuum hoses to make sure you get a nice tight seal. It's great for all your refrigeration connections because it's not going to contaminate the system. So find out more by going to refrigetech.com. You can also go to truetechtools.com. They have refrigeration technologies products right there. You can find out more there. Also, want to quickly mention solder weld. You can find solder weld products on truetechtools.com. You can kind of browse around at the different kits. The HVAC all-in-one kit with the 15% silver solder, I'm going to highly suggest that you find somewhere to buy that from. If you have anywhere locally that sells it, then buy from there. But if you can't find anywhere locally, then go to truetechtools.com and buy it there. If you want to get one of your local distributors set up with solder weld products, if you've been around me for any amount of time, you know how much I talk about them because they're great. Go to productsbypros.com, and give them information there about who you buy from and who you want to have bring it in, and then they can use that information to try to get solder weld at a supply house near you. All right, back to John. Yeah, so from the standpoint of balanced ventilation, so when we're talking about ERV and HRV, we're talking about balanced ventilation, which is keeping the pressure in the house in general. I mean, you still have your single point exhaust, and so the home is going to tend to be, even if you balance your other whole home intake versus exhaust, then your house is still going to tend to be a little bit on the positive pressure side. But in a balanced ventilation system through the whole home, you're putting out the same amount that you're bringing in. And so why would that be a good idea versus going with a pressurized type of design? This is something I've heard a lot of debate about.
So it depends on where you are. If you're pressurizing the house, like in your climate, in the hot, humid climate, there's not a big risk in terms of the building enclosure. You know, you're pushing out conditioned air through your walls, through your ceiling, or what have you. In colder climates, though, in the wintertime, when you're pushing out warm, humid air out through your walls or out through your ceiling, you can have situations where that warm, moist air, the moisture starts to accumulate, especially in the exterior sheathing of the house, especially in exterior roof sheathing, if it's a cathedral ceiling or something like that. And you just start to get huge amounts of moisture accumulation and potential rot or mildew or mold buildup on those surfaces. So that's kind of really the big danger. In your climate, the danger would perhaps be more if you were using exhaust ventilation systems for your whole house ventilation. And this is pretty common in colder climates in the Northeast, for instance, where you'll see a lot of times kind of the low-end ventilation solution is having automatic controls on the bath fan, one or more bath fans, or having one dedicated bath fan that runs constantly at whatever flow rate you need. And so your outside air isn't coming in through a dedicated source. It's just coming in through all of the different holes and cracks in the building. And in a cold climate, that from a building durability standpoint, that can be okay. From a control of the ventilation system, that's really pretty poor. You don't have any control over exactly where the air is coming from or where you're delivering the air. So that's a system that we don't really like to see.
So when you say it's not ideal from a control standpoint because you don't know where it's going to come from, I'm thinking, yeah, I mean, it's going to come around windows and under doors and through wall cavities and all that. And that doesn't seem ideal for a lot of reasons, but one of them, of course, being that a lot of those spaces that air is going to be pulling across or can be fairly dirty. And so you're going to be getting very unfiltered, potentially quite dirty air coming into the space through those gaps and cracks.
Right. You don't really know the quality of the air that you're going to get through those means. And you don't have control over how much air you're delivering to the different spaces. If you have a big hole somewhere in the house, all of your outdoor air might be coming through that big hole into a random closet in the downstairs rec room that nobody uses anymore, instead of having good control over the ventilation and being able to deliver it to where the people are.
Does 62.2, aSHRAE 62.2, does it have any requirement for testing to make sure that the ventilation system that's been installed is actually meeting the design requirements?
I think that's presumed. We don't really have to look into the standard for sure. I can't say off the top of my head. I think the standard presumes that someone is actually measuring the airflow to confirm that the ventilation system is doing what it's supposed to do and not just as a number on paper. And we see a really big range of performance of ventilation systems going from the page or the screen to real life.
So speaking of that, I mean, since you've been around the block for a while now, what are some of the things that you typically see as some of the challenges between what you design or what you want to see happen and then what actually happens in reality?
I guess the most common ventilation system that we see in houses that we don't design, but something that we're inspecting or testing is what's called a fan cycler system. So that's a outdoor air duct that's attached to a return plenum of a furnace or a heat pump. And it has a motorized damper on it and the control timer that tells the damper to open and tells the air handler or the furnace to turn on and circulate air. And that pulls some air from the outside. And what we see in those systems, of course, one of the big problems that we see is a lot of poorly installed flex duct on the outside air duct. We see a lot of flex duct because it is important, especially in colder climates, to insulate the outside air duct to prevent condensation, because that outside air in the wintertime is cold, so the duct is cold. So you do want to insulate that duct to prevent condensation. But of course, inexpensive way to do that is with a pre-insulated flex duct that often gets poorly installed. And so we see poor airflows because of that. The other thing that we see is we often see relatively good duct installations from a return side static pressure standpoint. And these fan cycler outside air systems rely on the pressure relief nature of that duct in order to pull the outside air in. So if your return side is already really, really low pressure and that outside air damper opens up, it's not a big pressure relief, so you don't get a lot of flow through that duct. And then building on top of that, if you're dealing with a variable speed air handler or a multi-speed EC motor, usually there's a fan-only setting that's set up by the installer at maybe 25% or 35% of the maximum. And so you have an even lower return side pressure situation. So you get even less airflow than you think. So in order to get 100 CFM out of those kinds of systems, you either need a really big outside air duct or you need a powerful fan motor combined with kind of a more restrictive return side duct system, all of which are not all that desirable from an energy efficiency standpoint.
Right, and that's what strikes me, that the thing that sometimes is missing in these standards that are maybe very well-meaning is the sort of test-out nature of what has to be done in order to prove that these designs are really working. Because, for example, if you designed a particular duct size, so you're running in a 6-inch outdoor duct in snap lock, a round snap lock or something, and you had very, very low return static pressure because the return static pressure isn't always going to be high. Let's say you have a direct return and it's a very large size, you may have a nice low static pressure, and that's desirable for the system. But like you mentioned, it's not going to bring in much in the way of outdoor air. Or on the other hand, and what we see, because we see the exact same thing in new construction. I went to a house, and again, I don't say the M word, but we had, I say moisture. Moisture is a word I can say. But they use one of these systems, and it just dumps outside air right into the return box underneath this unit that's set very, very cold in a short-term vacation rental community. So a lot of these guests are setting the things to 69, 70 degrees. And you can only imagine what's happening when that outdoor air is hitting that return. Especially adding kind of insult to injury now, you're cycling the blower. And so in running the blower, that's going to re-evaporate moisture. That's going to increase your indoor relative humidity. And so now you've got nasty growth on top of high relative humidity, on top of low indoor temperatures. And it just creates this, essentially a petri dish underneath. And this is all created by a standard that was designed to make air more healthy. And the result is that now we have this duct board. Of course, that's the other thing. In Florida, we have duct board everywhere. So now we've got this duct board petri dish underneath this air handler. And me as a servicing contractor, I'm kind of at a loss. It's sort of like, yeah, I don't want to cause trouble for anybody, but this is the standard. This is how most of these systems are installed, even in our market today. And all I can do is thank God that I don't do residential new construction. So So do you have any thoughts on that, like how that can be approached? Because this is a real problem in the entire Southeast.
Yeah, the standard doesn't really tell you how to do it. The standard tells you what the airflow needs to be and what the filtration requirements are and things like that. But the standard doesn't tell you how to do it. The standard doesn't tell you what the implications are going to be for your particular building and your particular climate. And so that's really where the practitioners have to figure that stuff out and think about the house as a system instead of just checking a box, a code compliance form, or checking a box on that you're meeting the airflow requirements for a particular standard. Yeah, and so in different climates are going to have different issues that you have to deal with. In the Southeast, definitely the outdoor air moisture in the summertime is going to be the primary one. And in starting from scratch in new construction, I think the answer is definitely you have to have some kind of preconditioning system that's going to wring out some of the moisture, if not all of the moisture from that air. In terms of going back and fixing those systems, that's of course more difficult to do depending on how much access you have, how big the mechanical closet is, and things like that.
Yeah, but it sounds like ventilating dehumidification is probably one of the best options in our market, especially given that using a positive pressurization method for ventilation isn't necessarily a bad thing where we are.
Exactly. Yeah.
That's sort of the conclusion that I've come to. And again, thank heavens we don't have to deal with it too much because we don't do new construction. When we do add-on and replacement, we sometimes offer ventilating dehumidification, but that's essentially is what I come to as being our only really good solution. Because in most cases, an ERV still isn't going to temper the air enough from a moisture standpoint to make it safe to stick it in the return anyway. And really, there's nothing safe as long as and so this is kind of the point I want technicians to hear. Dewpoint is so critical, and John's done a lot of really great stuff on Dewpoint, but Dewpoint is so critical. If you take air that has a dew point over the indoor temperature and you bring it inside, it's going to drop moisture out of it, and that's going to result in problems. I can't see how I'm missing anything there, but am I missing anything there? Is there any caveat to that?
No, I think that's pretty straightforward. I mean, maybe the only thing I would quibble with just a little bit is whether or not the ERV can wring out enough moisture. But there's a lot of variables that go into that, including the performance of that particular ERV and the actual airflow rate and whether or not the indoor air is dry to begin with. Because the ERV doesn't work unless the indoor air is dry. Or the moisture transfer rate, it's not a fixed property of the ERV core. You have a test rating that's done at a particular test conditions, but when the indoor air is more moist, you're going to transfer less moisture. So kind of if you're starting off with a very low temperature, high humidity situation inside, like you might have in a rental property, that's where the guests have just arrived, but they've been running the system for a few hours, then the ERV isn't going to transfer a lot of moisture necessarily.
Yeah, that's a really, really good point that has to be considered. And this is sort of what I was talking about before with the running the fan in the on position and just bringing it in on a timed basis from the outdoors for the whole home. In Florida, that's a double whammy of nastiness from a humidity standpoint, because we know that when you have all of that moisture that you've condensed on the evaporator coil, and immediately as soon as it cycles off, you're now re-evaporating that moisture in the on cycle. Then you add in outdoor air. Now you're making that worse as well. And in our marketplace, we're just working so hard to try to get to that 50% relative humidity mark. In many cases, we're losing the battle and we're slipping over 60. And like you're saying here, if you're already losing that battle and that's the air you're exhausting, then you're not going to remove as much air or as much humidity from that moist air that's coming in from the outside as well. So that's a very good point. And you got to think about all those things when you're choosing a design. So what else do we need to cover here to make sure that we don't miss anything in the ventilation conversation?
You, of course, have a hot, humid bias, but I think in colder places, in tight homes, the ventilation system is actually what is drying out the house in the wintertime. Or in tighter construction, it's keeping it dry enough to avoid problems in the wintertime. So you can have situations in cold climates where your relative humidity is too high, even though that's not kind of the common conception for anyone who's lived in a leaky, drafty house in a cold climate. Those houses, of course, are extremely dry. But in newer construction, tighter construction, that ventilation system is often what is keeping the house dry enough in the wintertime. So that's another reason to have good control over your outdoor air. The other things that we like to think about just from a general ventilation standpoint are thinking about the interactions between local exhaust, whether it be really kitchen exhaust, I guess would be the big concern, is thinking about kitchen exhaust and any natural draft combustion appliances, whether they're furnaces or water heaters or fireplaces or wood stoves or things like that. So we often will see in our new construction work custom homes where the client wants a large capacity range hood to go with their large capacity cooktop, but they also want a natural draft open fireplace at the same time and a tight house. Or the builder they build tight houses. They've built so many tight houses, they don't know how to build a leaky house. And so we get into kind of health and even potential life and death situations in those kinds of scenarios. And we start to have to think about dedicated makeup air for the range hoods in those situations if we can't talk the client out of the fireplace, which we're historically unsuccessful on doing.
Talking people out of things that they want is a tricky business, yeah. It's funny because my brother just built a house, and he's a really smart guy. And he put in a ventilating dehumidifier and all this, but he's got the big range hood, and he has a fireplace. And of course, we're from Florida, so we don't know anything about fireplaces. Like, we really don't. I mean, we never have them. It's sort of a novelty, and that's why you want one in your house, because it's like, hey, it's cool, we fire. So around Thanksgiving, he was having a bunch of family, his wife's side of the family over, and I knew they were going to have a fire in the fireplace because they just moved in the house, all this. And so I sent him a text message, and I said, hey, I'm going to be really interested to see if you can actually get a draft up that chimney. And I guess he didn't read my text, or maybe, who knows, maybe he'd been drinking or whatnot. And so a day later, 2 days later, whatever it is, he sends me a text and he says, yeah, I was wondering why that wasn't working. So yeah, we're idiots in Florida. But yeah, it's a perfect example. And actually, somebody brought that up the other day. I don't know who I was talking about. If you have a fireplace that's actually drafting from the space, I mean, it is essentially sucking on the entire house. It was Jack Rice who was talking about it. It is actually drawing on the entire house, and there's a significant amount of air that's going up that chimney. And in some cases, you may be radiantly heating that one room, but you're essentially cooling the whole rest of the house if you have a fairly leaky structure.
Yeah, the fireplace is with a good fire in it is going to be, I think, in the 300 to 400 CFM range for an open fireplace. So it's exhausting 300 to 400 CFM out of the house. And then that amount of outdoor air is going to be coming in where it can. When you get into the big range hoods, though, is if you're having that big party and you're doing a bunch of cooking at the same time in the kitchen, and your range hood fan is going to be more powerful than the fireplace, perhaps, than the draft of the fireplace, if you have a tight enough house. And you can start to backdraft the fireplace, start to get some smoke roll out and things like that, which if people are around, that everyone's going to notice that, and hopefully someone will turn the fan off or put out the fire. But it gets to potentially be a really dangerous situation at the end of the night if somebody has left an exhaust fan running, and the fire is smoldering and dwindling, but is kind of backdrafting unbeknownst to everybody else in the house. And then you get into a potential carbon monoxide situation, which can, of course, be deadly.
Yeah, and also water heaters too. So if you have a gas water heater, and then that can start to backdraft, and you can have carbon monoxide there as well. So lots of reasons why you don't want a house that has combustion appliances being under negative pressure. When no matter really what you're burning, it's not something you want to have significant negative pressure.
Right.
Anything else?
I think we covered all the big points that I had on my note sheet here.
Good. So anybody who likes what they hear from you, maybe wants to reach out or wants to find out more about what you're doing, what are some ways that they might be able to do that?
They can certainly email us or visit our website. We're also now and then commenters on the HVAC School Facebook group and on Twitter as well.
Yep. And so that is Think Little. That's John's company. And if you're in that Central Virginia area, beautiful part of the country, I think it was 3 or 4 years ago, we went and visited Monticello and Charlottesville, and really, really beautiful place. I think Monticello is probably in need of a little bit of home performance updates, I would guess.
All kinds of updates, but definitely home performance as well. Yeah, that's just up the hill from my house.
Oh, very cool. Very cool. All right, John. Well, thank you so much for taking the time to discuss this, and I'm sure we'll find opportunities to talk again sometime soon.
Great. Thanks, Brian. It's been fun.
All right. Thanks to John. Thanks to Neil Comparetto, actually, is the one who set me up on this podcast with John. Neil is a longtime contributor to HVAC School and all of its different iterations. He's a very good encouragement to me. He's one of those people who will call me out if I get a little out of hand, and I do sometimes. I'm actually kind of an emotional guy. A lot of you may not know that, but I do sort of wear my emotion on my sleeve in a lot of cases. And I'm very public with my thoughts, and sometimes I get a little carried away, and we all need people to rein us in. And Neil is one of those people who I trust to do that for me. So thank you, Neil, for all you do for HVAC School, for myself, and for the industry. And there's many others like Neil that I can name. And it's a long list, so we won't do that right now. But you know who you are. Anybody who's made the industry better, who's participated in the Facebook groups, who's commented, who's shared, who's corrected me when I make a mistake, I appreciate you, and keep up the good work. All right, thank you for listening to the podcast. If you haven't downloaded the app yet, you can do that easily, Android or iPhone. You can go to the app stores. You just look up HVAC School. In fact, if you just type in HVAC in the iPhone App Store, whatever you want to call it, the App Store on your iPhone, we're one of the first results. That's kind of cool. We haven't had the app out that long. It's a simple app. It's got some nice calculators in it. You can listen to the podcast, search and read the tech tips. But it's already made it almost to the top of the list, which I think is pretty awesome. And that's a testament to all of you who have given me nice reviews and been so kind and supportive. I don't know if you know this, but Stephen King has a son named Joe. I'm not joking, but he is. Oh man, these jokes are terrible. All right, thanks for listening, and we will talk to you next time on the HVAC School Podcast.
Thanks for listening to the HVAC School Podcast. You can find more great HVACR education material and subscribe to our short daily tech tips by going to hvacrschool.com. If you enjoy the podcast, would you mind hopping on iTunes or the podcast app and leave us a review? We would really appreciate it. See you next week on the HVAC School Podcast.